Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 15 of JEE Mains 2016 physics paper. So let us start with question number 15. Students, let us start with question number 15. It says two identical wires A and B, each of length L. Two identical wires, each of length L. This is A, this is B. Length L, this should be L. Carrying current I is the current I. Wire A is bent into a circle of radius R. This wire A is bent into a circle of, this is a wire A of radius R. Suppose the current is flowing in this direction. The direction of flow current is immaterial because we don't we have to find the relations actually. So it is anti-clockwise or clockwise, it is not important. So this first wire is made a circle of radius R, and the wire B is bent to form a square. This wire is bent to form a square of side A. So this side is A, each side is A. If BA and BB are the values of magnetic field, BA and BB are the values of magnetic field at the center of circle. So at the center of the circle, the magnetic field, it says, is B of A wire, and for this the magnetic field is at this center is B of B, because the wire is B, the wire name is B, is the magnetic field of B, this is the magnetic field of wire A. Then what is the ratio of BA upon BB? So you have to find BA and you have to find BB and see what is the answer. So we can take in any direction the current that is flowing in the wire. The current is I, obviously. We have to find the current magnetic field at the center of a circular coil. The formula you are going to use directly, and also for this. BA is basically the magnetic field at the center of a circular coil of single turn. Number of turns is 1. General formula at the center of circle is mu naught upon 4 pi 2 pi Ni divided by the radius. Here N is the number of turns, which is 1 over here because it is made to form one coil. Therefore N is 1 and radius is R I have taken. I is the current that is flowing. So from here if I solve this, this is 1. So 2 pi cancel, 2 will be there. So mu naught I upon 2R. Pi cancel, 2 will be there, 2R will be there, and mu naught I. So this is the equation 1 from we get the magnetic field at the center of circular coil. Now what is this R? We have to write R in terms of L because the length of each wire is L. So R is unknown but L is known because we write in terms of L. So we can write that 2 pi R, the full length of the circle is made out of the wire of length L. So therefore R is L upon 2 pi. If I substitute that, mu naught I upon 2R, R is L upon 2 pi, L upon 2 pi. So this becomes BA becomes, you can see that 2 will cancel, mu naught pi I by L. This is, I will say, equation 1. The next part is to find the magnetic field at the center of square loop here. So for each wire, the magnetic field is contributed. For this wire, it is like this. If I hold like this, then magnetic field will be out of this. So it will be out of the plane at the center. So for this also out of the plane, this also out of the plane, and this also out of the plane. So all these wires, 4 different arms, will contribute to the magnetic field pointing in the same direction vertically upward. So they will all add up. So whatever is the magnetic field due to each length of or each side, that you multiply with 4, that will give the magnetic field at the center of the square loop. So first of all, we have to find the magnetic field contributed by the single length of the wire. So let us find that. If I see this, then this is a square. So this point will be the center of this, and this distance is the perpendicular distance from this wire which carries a current I. We know that for a general expression, if you have a wire of length, any length L say, and from the center, if I draw a point here and a line which is a perpendicular distance, if this distance is suppose x, and this wire which carries a current suppose I, if this point, this angle is suppose theta 1 and this angle is suppose theta 2, then we know that due to a wire of finite length, the magnetic field at this point at a distance x will be mu naught upon 4 pi I upon x sine of theta 1 plus sine of theta 2. This is the formula you are going to use. Now theta 1 and theta 2, you have to find that this is the angle between the line, the perpendicular line, and the tip of the wire extending whatever angle at the point. It is the angle between those two vectors. Now if I see here, because it is square, this one will bisect this angle. So this will be 45 and this will also be 45. Because this is 90, this will also be 45. So this is 45. Obviously symmetrically this will be 45. So here my theta 1 and theta 2 are all 45, and this is the wire, and this end is projecting at an angle of 45, and this end is also projecting angle of 45 at this center. So I will write theta 1 and theta 2 as 45, and this distance I have to find. This total distance is A. So from here to here the distance will be A by 2. Exactly it will be halfway mark, and this distance is also A by 2. So this distance is A by 2, this distance is A by 2. So in place of x we have A by 2, and theta 1 and theta 2 are 45 degree. And we have a relation like 4a. This A 4a is made out of this length L. So we'll have one relation that L is 4a, so A will be L by 4. So this x will be A by 2, that is L by 8. So this is L by 8. So this will be L by 8, Now I'll substitute the value. The magnetic field at BB will be equal to, BB means for B wire, mu naught upon 4 pi I upon x, x is L over 8, sine of theta 1 sine of 45 degree plus sine of 45 degree. Sine 45 1 by root 2 plus 1 by root 2, that is 2 by root 2. So it is 2 by root 2, 1 upon root 2, 1 upon root 2, 2 upon root 2. So this is mu naught upon 4 pi 8I by L 2 upon root 2. If I solve this, then this becomes 4 to the 8. This will be 4 upon root 2, 2 to the 4, 4 upon root 2, mu naught I divided by pi L. This is due to contribution from only one side. For 4 side, this total BB due to all 4 sides. It will be how much? It will be that BB will be 4 times the value that is we have obtained so far, 4 upon root 2 mu naught I divided by pi L. So this is if I write then 8 root 2, this will become 8 root 2 mu naught I divided by pi L. This is B, equation number 2. Our aim is to find BA upon BB. BA we have got BA from equation 1. I'll write BA upon BB. This is the question. BA already have got this, mu naught pi I by L. And BB we got here, that is 8 root 2 mu naught I divided by pi L. Mu naught I will cancel, mu naught I and this mu naught I will cancel, this L and this L will cancel, pi and pi will be pi square divided by, this is 8 root 2. So pi square divided by 8 root 2, it should be the answer to this question. If I see the option, it is pi square divided by 8 root 2. So this option number 4 is correct. So option 4 is correct. Okay, thank you.